Hello, everyone. Welcome to our review of rounding. So calculations in business are usually done using computers. You're going to be using calculators or Excel or some other computer assistance to actually do calculations. And the answers often come out with long strings of decimals like the examples shown here. Okay, long strings of decimals meaning long strings of digits after the decimal points. The thing is when we're communicating numerical information to other people, rounding the numbers helps us speak about them more efficiently and to produce readable written work that is understandable, right? If you leave on all of the decimals, it's just going to clutter up what you're looking at. It's just going to add irrelevant information to the situation. So what rounding is, of course, is shortening the numbers to show the most relevant information. So as a student, you're going to be rounding numbers constantly to enter them into exams, into homework programs, into various software. But it's even more important to focus on this because you are going to be rounding numbers all throughout your whole entire business career. So solid grasp is essential. Now, when you round numbers, they are rounded to a specific digit. So each digit in a number basically exists in what's called a decimal place. Every decimal place has a name. These decimal places are relative to the decimal point. You know, a lot of math people would at this point be like, deci means 10 and we have 10 fingers, but you can look up the basis of our counting system if you like. What we're looking at is the common decimal places that you are going to encounter. Of course, numbers can have digits infinitely to the left and infinitely to the right because they can be infinitely large or small. So I'm giving you just a selection. But these are very common ones. And as we're looking at figure 1, what you're seeing is that these decimal places have multiple names. And this is where I'll tell you, this is very common in math because math is an ancient discipline. And the same concepts have been approached in a multitude of ways. And depending on how those things have caught on and become useful, those ways of speaking about those things have also caught on and become useful. And so we have multiple ways of referring to the same thing. This is just a complication of being a human at this end of all the knowledge that we're building on, right? So if you look at the top, what you see is that each decimal place has a name, like the 10 digits, 5, 6, 7, 8, 9, 10. Yes, 10 digits to the left of the decimal place is the billions place. Just directly to the left of the decimal place is the ones place, right? That's where you count the ones. And in the tens place, that's where you count the tens. Now, when you go to the right of the decimal points, you get into fractions of 1. Why? Because if you had a whole 1, you would just put it in the ones place, right? So we keep track of things smaller than 1 in these decimal places to the right. So the first one to the right of the decimal point is called the tenths place, then the hundredths place, and so on and so forth. Now, if you look at the bottom set of labels, what you see is, the decimal point, that's the decimal point, and you see that the decimal places that are to the right of the decimal point have other names. First decimal place, second decimal place, third decimal place, fourth decimal place. And what you should notice is that those are referred to by the number of their place to the right of the decimal. So to extend that further, we see that the millionths place in this figure, which is occupied by the digit 9, that would be the 6th decimal place. It's not labeled on the figure, but we can count and see, and that's how the pattern goes. So suppose a number is to be rounded to the 4th place after the decimal points. That could be indicated in a number of ways. You could be told to round the number to the 10,000ths place. You could be told to round the number to the 4th decimal place. Or even shorter and more efficient, you could be told to round the number to 4 decimals. All of those are saying the same thing. They're all in common usage, so you should know what all of those ways of saying the same thing mean. Now, rounding is done to a particular digit or decimal place, which I will be calling the round to digit. So if we're supposed to round to the 3rd decimal place, that 3rd decimal place is the round to digit. Table 1 shows the basic algorithm for rounding. It will suffice for almost every, well, not almost every, but most of the times that you have to round. And we will go over some modifications and wrinkles in the application as we go. So the algorithm is, step 1, you look at the number in the decimal place directly to the right of the round 2 digit. So if you're rounding to the 3rd decimal place, you're going to look at the 4th decimal place. That number, 1 place to the right, is the only number that matters to make this decision. Many people think that you need to go all the way to the right and start rounding from there. You do not. You just need to look 1 place to the right. Step 2. If that number, 1 place to the right of your round 2 digit, is 5 or more, you round the number up by increasing the round 2 digit by 1 and leaving off the rest of the digits to the right. If that number is 4 or fewer, round down by leaving the round 2 digit as it is and leaving off the rest of the digits to the right. So that is our basic rounding algorithm. This applies most directly to numbers that are being rounded to decimal places to the right of the decimal point, but we can still use it even when we're not, as we shall see when we proceed through our examples.